the last nut of your anchor bolt and you want to replace it, first you have to determine the kind of thread on this piece of hardware. In this video, I will show you how to determine the thread pitch for metric threads or the TPI number for inch-based threads, and this determination or calculation method will work for any of the inch-based thread standards. I wrote UTS, Unified Thread Standards there. It works with any of them or the metric as well. From then on, we will take the concept of pitch and we'll explain how tightening or preloading a bolt actually works, and we'll then move on to briefly go over one of the ways to preloading a bolt in a calculable or predictable manner is the turn of the knot method, and we'll briefly mention its pros and cons. Let's get started with pitch. Just what is meant by pitch? The pitch is a horizontal distance. Pitch is a distance. A horizontal distance on a thread from crest to crest. It is the distance the knot advances in one turn. It's important that you understand and memorize the concept and definition of pitch. That pitch represents a horizontal distance the knot moves forward in one full turn. So if the edge of the knot was at this crest, if it rotates around once, the edge of the knot will be here. If it rotates around one more time, the edge of the knot will be here. If it starts at this root here, where the edge of the knot is, in one full turn it will be there, and in one more turn it will be there. This is pitch. A pitch is a horizontal distance. It's very important for the concept of preloading or tightening a bolt. So this is how you determine the actual number of it. You grab a tape measure and you line it up like so. You line up any of the crests or any of the roots, for example, but we'll go with crests on this one and we'll go with the roots on the other one, on a metric example. You line up one of the crests with one of the lines here. This is ½ inch. Actually, it's going the other way around. This is 0 and this is going to be ½ inch for, it's easier to read from your point of view. Oops. And we count the number of turns from here on over a certain distance. This is 1, starting from here, so that's 0. 1 full turn, 2, 3, 4, 5, 6, 7, 8, and 9 full turns over a distance of ½ inch. Now, let's double it. So that's 18 turns over a distance of 1 full inch. And I'm going to write that one down. 18 turns over a distance of 1 full inch, or 18 turns per inch. 18 TPI. 18 TPI is typically how threads are specified. So if you counted the number of turns over an inch on this one, you would come up with a number, say 8 TPI or whatever it is on the big anchor bolt. On this one, it is 18 teeth per inch, and that also means that the pitch from one crest to another crest, or from one root to another root, same thing, is exactly 1/18 of an inch. It's a fraction, don't worry about it. If you want, convert it to decimal. If you want, convert it to metric. Hey, in a decimal format, it's going to be 0.055555. It's an infinite decimal, and in metric, if you multiply this number by 25.4, you're going to get a 1.41 millimeter distance. Millimeters, decimal inches, fractional inches, it doesn't matter. It takes 18 turns to cover a length of an inch. Any knot would need to turn around, 18 times to advance a distance of 1 full inch. This is very important for the concept of pitch. Let's quickly look at a metric example. Just super fast here. Say, how about we line up those ones there. Okay. So, on a metric, determining the thread pitch is very similar to an imperial method. Like I said, they are totally similar. So let's start at this crest, or you know what, I said let's start at a root, so I will set it that way, just finicky, hold up. There we go. That's good. Let's start at a root on this one. So we start here at this particular root, and I lined that one up with this centimeter line conveniently. And here is turn number 1, and it's a little more than a millimeter. Turn number 2, root number 3, root number 4. It seems to me that the 4th root here, so the knot taking 4 full turns, after that it travels 5 millimeters. It seems so. You can see that from this root to this root, the distance is slightly more than a millimeter. And actually it is like 1.25 millimeters. But let's double it and see if it checks out over a longer distance again. So that would be the 5th, the 6th, the 7th, and the 8th root. Yes, it does check out. The 8th root lines up with another multiple of 5 millimeters. So we have a total distance of 10 millimeters. And we have exactly, that's the 8th turn, 8 turns. And that gives us a pitch of 1.25 millimeters. So on this one, this is the pitch, 1.25. Now, 1.25 millimeters. And on the previous one, it was 18 TPI. Now, how preloading and tightening works. I have this piece of foam here, and okay, this is going to be a bolt now. When the knot can advance on a thread unrestricted without clamping any wood or metal or any material together, it will just spin happily ahead. If it's got something in the way here, say here, the knot will only come up to the edge of this surface here. From here on, and this is important, from here on, from this obstacle, if the knot is forced to travel along the thread, it will so, but it will not get closer to the head of the bolt. See, if the bolt, if the knot, okay, here is the knot is traveling here, this is knot, and it's traveling in that direction, and this is say the knot hits something here that it can't go past by, and maybe I'll put it in the, well, I can't move it, sorry, because I wrote it on the whiteboard, not on the projector. Okay, so if the knot can't go forward but is forced to turn, it will turn and it will travel along the thread, but in the meanwhile, this is what's happening to the bolt. It stretches. If this is the head of the bolt and this is a nut, and if the nut is forced to move along the thread, but it can't because there is something in front of it, it's going to be clamping the material with a greater and greater force, and will elongate the fastener proportionately to the amount of travel that it's forced to take forward. Okay? For example, if you take a quarter turn on this nut, it will stretch the bolt a little. If you turn this nut half a turn, it will stretch the bolt more. Like I said, if you take actually careful measurements on the bolt, you will see that it actually physically stretches the bolt. And if you take say 1 full turn on this nut from the point again where it cannot move forward and it starts clamping the material, it will stretch the bolt to near breaking point and will actually strip the threads off the bolt or the nut, whichever is softer. So that's how the concept of tightening a bolt works, or preloading a bolt. And it's important that depending on the coarseness of the thread, see, this one is a coarse thread and this one is a superfine thread. Just see them side by side. It is obvious that the distance a nut would travel on the skinny bolt is way less than the distance the nut would travel on the big anchor bolt. So a quarter turn on the skinny bolt is tightening or preloading the bolt less than a quarter turn on the anchor bolt. Because a quarter turn means different lengths. It was on the Imperial bolt it was 1.4 millimeters. On the metric it was 1.25 for 1 full turn. It does make a difference if it's 1.25 or 1.41. So if a bolt is forced to travel along a coarser thread, a half a turn, it will tighten it or preload it more than if it's forced to turn or forced to travel along a thread with a smaller pitch. That's why engineers, that's why they are there for, mechanical engineers determine how many turns you should be taking with a nut, and it will only work for that size of nut in that particular application. Okay, so don't take it home and work on your car and eyeballing torque specification for any of your vehicles. For working on vehicles, have a torque wrench, please, a calibrated one. On the job site in construction and working on steel beams, the turn of the nut method works very fine. And like I said, if you exceed the specifications, instead of a quarter turn, you go half a turn. The more and more you turn, the greater and greater force you exert on the nut, on the bolt, and it will stretch longer and longer. So that would be its pros and cons. You have to watch out how much you actually turn on the nut, and it doesn't universally apply to any bolt. Not even if they are the same size, because some might be softer metal and some others might be harder metals, and it's pros. Sorry, that was cons. And pros, it's simple. You don't need to carry a torque wrench with you. So that's basically the lay of the land, and calculate determining the pitch of a thread until you are proficient with it.